The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing SolidCAM Live for the last day for me this week. And tomorrow we'll be taken over by my buddy. Your business is his pleasure, Kevin Rankel.
Wait a minute, we can't do that your kind of intro today when it's your birthday. I say we just
No.
start singing happy birthday, or I mean, we can unmute Scott and he could start singing happy birthday to you.
Are you just picking people at random now? Just
Yep.
Scott?
Because Jake isn't in here today.
Oh, Jake's not here today. Okay. Well, it could be someone else's birthday. It could be Brian's birthday. It could be Edwin's birthday. Just start naming names.
It's actually your birthday today.
Yes, it is. It is. So that's why I'm not here tomorrow. I will be waking up very early to go grocery shopping. But let's not waste people's time. We will be continuing what we talked about yesterday. And yesterday we were talking about the 5-axis capabilities inside the software. And there was actually a little bit of talk of wrapped geometries as well. So I actually got the part from yesterday, and I've added 2 tool paths for each feature that we would probably want to do. So I'm going to do a 4th axis simultaneous. This is actually the screw machining toolpath we were talking about yesterday. And as a review, the screw machining toolpath is not for a screw machine, like a Swiss screw machine. This is actually just the idea that it will follow the patterns of your part. So it's developed for these sort of feed screw impellers, this sort of helical shape, but you can really use this for any 4th axis part. It's really just a matter of having your stock and your target defined, because there is a little bit of a stock recognition in this toolpath, but you can see it follows the exact movement of the tools. So it's kind of a nice little flowing toolpath for this sort of feed screw, but also, like I said, it could be applied to pretty much any rotary part. So you can see what it does here to do this part. I can do the same thing, or somewhat of the same thing. There's a few differences we'll point out with iMachining. So we talked about yesterday how if I grab a wrapped geometry, so let me just show you the contour that I selected. That's actually wrapped around the part. Now with this, I actually have to do something a little different. You can kind of see that there's those yellow circles on the ends there. That's actually the open edge of the pocket. So this was wrapped, so I chose all the outside edges of this face, but I had to actually open that edge so it knows the tool can wander outside there. And I actually had to create that edge because this originally was one continuous surface. So this is a very useful tool, very useful use of iMachining, especially when you're trying to reduce cycle time on a 4th axis part. But it needs this sort of editing in the design. So you'd have to go into the part file like this, right click on design model, and actually create a plane there, and then what's called a split line. And a split line is essentially the cross section of that plane with that surface. So actually slice that surface. It still remains the surfaces of the solid. I didn't actually disrupt the solid in any way. So my stock and target just need to be resynchronized if it does even notice anything. But the use of that is to get that edge. And I actually had to do it a little bit past this point here, because if this was a continuous circle, then it wouldn't really count as the wrapped edge of the pocket. So that's just a little bit past that tip there, so I get a discontinuation there. So that actually acts like the edge of a pocket. So the idea that really to think about how you do wrap geometry is if you had, and it's a weird example, but in these times, everybody's gonna have one, an empty toilet paper roll. If you were to cut that and unravel it, you would get this nice looking kind of strip of paper. But when you roll it up, you get this conical shape. So that's exactly how you should think about that. If you look at it, how it's highlighted in the orange right there, that's essentially just a continuous pocket wrapped around the rotary. So when you do wrap geometry, think of it like that. And by doing that, I program it the exact same way I do with 2D iMachining. I just told it whatever tool I want. It's got those open edges, so it wanders outside a little bit, and we get that same sort of tricoidal toolpath that goes all the way along. And because it is iMachining, it's doing that full depth of cut. So you can imagine that we're actually getting some cycle time reduction versus if we were to do this with screw machining with depth of cut, step over, that sort of thing. The drawback though, go ahead, Kevin.
Well, what I was going to say is just to make sure everybody understands how the wrap works, you do need to have the part in the center of your coordinate system. So we need to be
Yes.
rotating around the center of
the rotary.
Of the rotary.
Yeah. This wrap geometry, like Kevin says, only really works on a 3+1 machine or a mill turn, where you actually have a center of rotation. Because when you do your wrap geometry, if I open this guy up again, and we click on, let's just say new geometry, you have to choose something to wrap it around. And it's really just the X, Y, or Z. So if this was on a mill turn machine, you can choose Z. If this was on a machine like this, 3+1, I choose the X. Or if you have one of those machines that's around the Y. Basically, you get to choose one axis. So your coordinate system, like Kevin said, has to be dead center. It has to be on the rotary, or else you're not really going to be able to wrap this thing around. If it's off center, or you've got some sort of embossment somewhere where you want to wrap around there, then you're talking about fourth axis simultaneous, and then you can choose your own axis. In this fourth axis simultaneous toolpath, we just go into that one real quick. It's called simultaneous 5-axis, but it's simultaneous fourth axis as well, because we can limit the travel of the tool. So we say fourth axis, under rotary, we can choose our own user defined. And then we just click on these 3 dots, and then you can actually define it by the first point, and then if I click on something, I'll get a second point. So I can actually define my own custom axis, and that gives me the ability to do wraps and stuff like that, but in simultaneous fourth axis. This is not the simple wrapped geometry that we're talking about here. So that's one limitation of this. The other limitation is if we take a look at this, actually, I want to see if I can get it kind of lined up like this. The other limitation is any wall of a pocket. Now, this part probably is not the best example of it, but if you look on the, there's a C-axis wrap training video on our YouTube channel. One thing to remember, and I'm actually probably just going to do this, and we'll kind of look at it from the side here. Let me get a little drawing tool. Is the wall has to allow, here, let me see if I can get a better color on this thing. Choose pen color, we'll do red. Okay, so for wrap geometry, the tool is always pointing, if I draw a tool like that, the tool axis, the tool vector is always pointing towards the rotary in wrapped geometry. This is not simultaneous fourth axis. If it was, we would get the ability to wander in the radial direction. But because we're doing wrapped, the tool is pointing right at the rotary. So that gives us some limitations when we do wrapped geometry. All the walls have to allow for, the walls of the pocket would have to allow for the tool to be parallel to it. Or else you're going to get, if you get a wall, let's say if we draw something over here, so there's my tool. Any wall that's not parallel to the tool, to the tool vector like that, we're going to get some excess material left behind here, because that tool can only be in that one angle. So if we were to compare the screw machining, let me just erase all this stuff. If we compare the screw machining to the iMachining, you can see there's a little bit of a fanning out there. You can see that the tool does go a little bit radial. I mean, obviously there's a step over, but I'm talking about how far away from center this thing gets to go. Whereas with the iMachining, if we see the tool, that's the center line of the tool. It has to be straight up and down. So any kind of angle on these vanes here, or these flights on the feed screw, or if you're doing a wrapped pocket, the walls of the pocket, if they're not parallel with the tool vector, then you're going to have either excess material or you're going to gouge your part, depending on if you choose the top or the bottom of the pocket. So if you're doing wrapped geometry of a pocket, I would say choose the bottom of the pocket, and then that way you'll at least have excess material that you can remove when you do a simultaneous toolpath. And that's what I'll be talking about in this next half here. But any questions on wrap geometry or the use of 2D iMachining in wrap geometry? And while we're waiting for questions, thank you everybody for the birthday wishes.
Can't let that go unheard. No, and one thing to think of too is if you guys have a pocket as well. So you know, we're showing on a feed screw here, but if you guys had an actual like a slot that is going around, that's where another great time to use the wrap functionality as well.
Absolutely. Anywhere where you can choose 2D geometry, you should be able to do a wrap geometry. I think the only places you can't is probably toolbox cycles and things like Contour 3D. Contour 3D itself is already three-dimensional. I don't think there's a way to do a fourth axis on that. But in that case, you probably wouldn't be doing that anyway, because if you're doing a wrapped, it already is moving enough that you can probably achieve whatever feature you're trying to get with the Contour 3D. But like I said, you can use 2D iMachining to rough out the core of this area, or you can use the screw machining, or you can use fourth axis simultaneous. All those guys allow you to choose surfaces or edges or contours to rough it out. But now it's time to do the walls. So with the walls, because the wall actually has a little bit of an angle to it, that is not fourth axis anymore. That is, well, actually it's not, it is still fourth axis on this machine, but it's not allowing us to just point towards the center. So we need some sort of simultaneous toolpath. And that's what we talked about yesterday. If I open this up, I used the simultaneous 5-axis toolpath, limiting the travel to only the fourth axis, and I used something like tilt relative to cutting direction, and I set it to 90 degrees. Basically what that will generate is, if we take a look at this real quick, is the tool will come down, and because I told it to rotate 90 degrees to that surface normal, we're getting it to use the side of the tool, and we're getting it to basically just be off center. If we can kind of see if I can get a good angle on this thing. So the tool axis is not necessarily pointing at the rotary. It's off center a little bit, and it gets it to be tilted. So this is still fourth axis, but we're getting it to tilt in that fourth axis to achieve the cut that we're looking for. And that's easy enough. All I had to do was just choose that surface. So I get it, the surface I want to machine and the surface normal that I'd like to tilt to, the 90 degrees. I'm choosing the bottom edge of that face there, because when you do something like this, you're modifying this to do a type of Swarf cut. When I say determine my number of cuts, it's basically just going to follow that curve along that surface and generate that cut that we're looking for. If I exit out of here, we get what could be called a Swarf cut. I'm going to get that tool to just use the side of the tool to finish that face there. Now, I'm calling it a Swarf cut because that's what it's kind of, I mean, that's what it is, right? We're using the side of the tool, we're doing that surface. In that case, I could have actually used the Swarf machining toolpath that we talked about yesterday. In that case, we actually do it pretty much the exact same way. If I go back to the geometry section, strategy-wise, we have it set to automatic, but I could tell it to do various ways of how to tilt the tool. But I'm going to get it to figure that out for me by simply just choosing that surface. So it's basically the same surface that I chose. That's what I'd like to do. Because I gave it strategy, I don't have to choose anything else here. The tool is the same. Toolpath parameters, very much the same. There's a lot of stuff in here that is automatically detecting stuff for you. And then in the tool axis control, I really just had to tell it how to tilt. But I only have two options there. So this is automatically generating a Swarf machining, Swarf cut style toolpath. So like I mentioned yesterday, it's very bare bones. There's very few parameters here to play with because this is specifically for this type of thing. Whereas with the simultaneous 5-axis toolpath, I could still do the same thing. I just had to kind of modify the parameters to do those specific things I'm looking for. But if you look at the two toolpaths together, they are virtually identical. The only difference is one is probably dipping a little lower because there is a corner radius on my tool. So one is imagining that the imaginary corner of the tool, and I think we talked about this in a previous SolidCAM Live, but let's open up the tool table here. Okay, so this is actually a flat end mill. I thought I had a bull end mill, but so one of them is actually taking this corner of the tool and riding along my exact chain there. Whereas another one is probably dipping it a little lower because it recognizes something about the shape, something about the surface that the contact points aren't lining up. It has to lower it just a little bit. So between the two, you get those little bits there. Okay, so Brad is asking how to use the fanning and Swarf process. Okay, so let's get out of here. Okay, and he is talking about, not actually on screen, there it is. Okay, so let me just leave my mouse in there. So the fanning distance is unlocked here. We actually have to bring in something that is using it. Where is it in here? Do you know how to unlock that, Kevin? The fanning distance?
Yeah, undo your 4-axis and switch it over to 5-axis.
Oh, okay.
And
no,
because that's the only way we're allowed to do fanning. It's got to be something with the 5-axis. It has to be turned on for 5-axis.
Unless it's something that, since we have
Oh,
this
you
set
don't
to
have,
automatic.
yeah, you don't have a lot of the stuff picked in there.
Yeah.
That's
That would
probably
be
why.
that would be how you would unlock it, and then how to use it is basically relating to how you programmed it in the first place. So because I'm getting it to do an automatic strategy, it's locking out a lot of this sort of stuff. Again, this is a very dedicated toolpath. So there's going to be a lot of stuff where you can get it to do calculations for you and its own assignments. But if you went and took more control of this and you unlocked some of these things by checking boxes and you got it to better control the toolpath using those, then you'd get the ability to do some fanning. And fanning is basically like you see in that image there. It's actually going to tilt the tool either into the cut or away from the cut, depending on how you tell it to do that. And the purpose of that is to get that better contact point.
Yeah, and basically with like this part right now, that feed screw is perpendicular to our axis, so we don't need any fanning. But if it was at a specific angle where we would have to come in with the 5-axis, then it would automatically compensate and automatically tilt over one way or the other way, and we can contain that by a certain value with that fanning distance.
Yes, exactly.
Now, one thing before we get going too far, I really would like to see if we could do a 3D iMachine and do a transform 4 times to kind of lead off from yesterday too.
That's exactly the next thing I was going to get to. So I actually didn't do it here, but Kevin had reminded me right before the call that that's the other thing that we talked about, and that's actually one of Brad's suggestions. And it's a really good suggestion because if you have 3D iMachining, regardless of the fact that this thing is a 4th axis part, you have 3D iMachining, you can probably get some better cycle time without having to index this thing. You can actually just probably lock it in place, do 3D iMachining, do indexing 2 times or 3 times or even 4 times, depending on the reach of your tool, and you can get this thing done. 4 times probably is not going to be necessary here because I think I have enough reach on the tool. What do you think, Kevin? Maybe just do it 0 and 180, or do you think I should do it 4 times?
Well,
or for demonstration purposes, we'll do it.
Yeah, maybe just do it 2 times. And then, as you're starting that process, definitely think of this going forward for all you guys that are doing any kind of rotary work. Instead of going through all these different processes, definitely feel free to, I've done it on my old shop where we'll do increments of 45 degrees just because of reach, and just keep incrementing every 45 degrees and do a 3D iMachine toolpath that way.
So I'm just going to set this up exactly like a 3D iMachining. I'm going to put maybe a little more material so we're not here forever calculating this thing, but you can see that all the controls will be the same because again, we're still applying a 3D toolpath to a 3D part. The fact that the machine can index doesn't change anything with this. I'm basically just going to lock it in place and look at it like a 3D toolpath. So I've set it up with the Z-axis pointing in that direction, which is actually pretty important for wrap geometry as well, because remember that your Z-axis is your tool axis. So if you don't have a Z-axis pointing in this direction, the tool can't come from that direction. If the Z is pointing, let's say like it was over here, and you need the tool to come this way, and your machine has the ability to tilt the head, well, that's 5-axis. So you're going to do a simultaneous 5-axis toolpath to do that. If you're going to do any kind of 2.5D toolpath, 3D toolpath like I'm about to do here, or a wrapped toolpath, the Z still needs to point in the direction you want the tool to come from. In the case of a wrapped or a C-axis wrapped toolpath, the tool needs to at least come from a starting point before the whole part gets indexed. So the Z-axis is your tool axis, no matter what you're doing. Okay, so we've got this guy here. Let's see how long this takes to calculate. And I had to put it at the top of the toolpath list because, again, this is a recognition toolpath. So we want it to recognize all of the stock. If I had put it at the end, there probably wouldn't be any leftover material to machine.
Yeah, and that's why we do get a little bit longer calculation times with the feature recognition ones, just because it's going through, looking at the stock, looking at the target model, faceting everything, making sure it's not going to gouge, along with the iMachining algorithm there.
And let's make sure it doesn't crash. Okay. So what I'm going to do next, just so we can talk over the fact that this thing's calculating, is I will put in a index. Either I can set up another coordinate system, so I can tell it that I want to come from the other direction, or I'll put a transform in there. If I put a 4th axis transform, I'm essentially telling it to do the toolpath from the other side. But since this is still a recognition toolpath, it should recognize the geometries and automatically do it. But to be safe with the 3D iMachining, I think I'll just put in the index position, only because I want to make sure that it's looking at it from that angle, and also take the opportunity to show you how you could do that on this 4th axis part, if you guys weren't already aware. Let's see, this thing is, so it's faceting model. It's pretty much just rebuilding the stock, because remember, I already did 4 toolpaths to this. So it's actually trying to look at that fresh look. It's recalculating everything. And once it goes through that, those green bars will pass by real quick. But while this is going on, any questions? There's no questions. We did get renewed for the next couple weeks. We're going to be doing SolidCAM Live until the end of June. Tomorrow and Monday, I'm out of the office, so Kevin will be taking over, and Kevin will take the opportunity to do his favorite toolpaths and what he considers to be an underutilized toolpath. So tune in tomorrow for that, and Monday for KevCam Live during the day.
Yeah. We'll just sit there the entire time and just make fun of you, Mark.
Yeah, I know. So I guess I must have defined the stock all the way through, so you can see that it's going all the way to the end there. What you can do with this is you can set up a, let me open that back up. You can set up a working area. Let me try that again, double click. There we go. So in the geometry section, it's looking at the target, comparing it to the stock, and that's why it's milling everything. But if this has been turned, or maybe it's being held on that end there, and I don't want it to collide, and I haven't defined my fixture, I can use a working area, just draw a simple rectangle over this area here, and then just tell it to work only within that area, and it'll do the same thing. It'll just limit the travel of the tool. But you can see that it is actually roughing all of that out. I probably, if I had the reach, I probably should have said to go all the way to half. So instead of levels, I could have just put this at half. Now, since it took some time to calculate, I'm just going to leave it as is. But we'll rotate this. Well, we'll do 90 degrees each time. So let's go over here. And we'll do it this way first. So indexing. We'll include the original operation. We'll do an index of 90 degrees, and we'll do that for 3 more times. And then as soon as I click save, it's going to want to recalculate. But what that's going to do is it's going to take a renewed look at the stock at those 90-degree positions. So this is kind of like what Kevin was referring to before, and yesterday, this is what Brad was asking about. If you have 3D iMachining, you can actually get it to rough this out like this, and then go in there later with your simultaneous toolpaths or your Swarf toolpaths and get it to clean up those spaces. And if you're looking for a reduction of cycle time, this versus the wrapped versus the simultaneous toolpaths usually is a little faster.
Yeah, and like I said, this is, you know, to Brad's point yesterday when he was asking about this, this is one of my favorite features about 3D iMachining, because I can just, like I said, kick it over at 0, 90, 180, and 270 and get all the material come out to be pretty much eliminated out of there without having to do much thinking or much work. Now, coming to the finishing side of things, then you can really fine tune your finishing in there. So
yeah, I think I probably have to clean this part up, because you can see that we actually completely copied the toolpath. This is actually doing something that's not even there. So in the case of a recognition toolpath, I don't think we want to use transform. Let's take that off. We should probably use a just an index. So we've got some time left. I'll do that real quick here. Unless there's any other questions while you guys are on the line here. But I'm just going to show you how you can create some quick toolpaths or quick coordinate systems. So let's go right click. No, let's try it over here. So transformed copies. I will create an indexed copy. Again, we'll do 90 degrees. We'll do it number of steps 3. And axis point, we'll call this the x-axis. Now this actually creates MAC positions. In this case, I probably would have wanted to have made index positions. So I'm just showing you that because most people don't even know about the transform copies here, but let me get rid of this now and do it in the real way with just index positions. There it is. All right, let's just quickly add some more here. There is a question. So does the screw toolpath have any option for a thin wall finishing strategy? So finishing the wall at each level before going down to Z. I do not believe there's a thin wall strategy in screw machining.
We have to
Kevin, are you aware of that?
Yeah, I can't remember. There's so many different thin wall options inside SolidCAM. I can't remember which operation has it and which one doesn't. So maybe once you're done here, we can just open up that operation and take a peek.
Yeah. So to get the proper index positions, I'm using center of revolution face, and then I'm just going to set this up, but with the Z pointing in the direction that I want it to be in. So let's start by putting it with the x-axis in the center, like that. And then the Z, let's rotate around X to get Z at that 90-degree position. And then green check mark. And another question, yes, Brad, I will send you a copy of the part. So anytime you guys want a copy of the parts, I can send you a copy. This one, I'm not sure how large this file will be, but I will upload it to OneDrive, and then I can send it to you. Okay, and let's do a flip around Y. That one's already in place. Okay. There's a lot of toolpaths in here, a lot of code in here, so it's probably slowing things down. But I just got one more index position to create.
On top of your computer being old.
Okay, indexed positions, perfect. So for indexed machining, basically, if you haven't done this before, all we're really going to do is just change the MAC position in the toolpath. So I'll open this guy up. I will make a copy, so save and copy. And in this case, I don't have to change anything here because it's already looking at the target. I'm just going to tell it to look at MAC 1 position 2. My levels, most likely they're the same because those are radial levels. I'm just going to click save. And then I'll do the same thing, save and copy. Change to MAC 1 position 3, save. And you can see that there is no other icon here because this is a recognition toolpath. It needs to see that updated stock. And at this point, I have some toolpaths that have not been calculated ahead of it. That's why it won't calculate at this point. So I'm just going to make my change, do a save, exit out of here, and then highlight all 3.
But before you do that,
all right,
let's go ahead and open up that that screw machining operation that you have, and let's look for that thin wall because if we do a calculation, if it takes too long.
Yeah, yeah. So there's not going to be anything in here. Levels obviously not there. Adaptive step down might be the closest thing because it gives you the ability to change the number of steps. Trim. Yeah, nothing really there. Smoothing.
Yeah, so we can do by levels as well. So that may help you out, Clinton, instead of regions. So what it's going to do is, what I'm guessing you're wanting to do is do everything on that level and then move down to the next level. Is that correct? Yeah.
I think so. I think that's what that does.
Yeah. So that's machine by levels is kind of set up for that thin wall feature for you. Now, like I said, some of our operations do have a specific call where it says thin wall. It's just like I said, there's, as you guys know, there's tons of different options inside SolidCAM. So to go through and find which one has it and doesn't.
Yeah, so the ones that I'm aware of is not engraving, but toolbox cycle. So there is a thin wall option right there. And I believe it's in the profile toolpath as well. There's something that calls out thin wall. Yeah, so thin wall strategy.
Yeah.
If you do clear offset.
Clear offset.
Yeah. Okay, let's calculate these guys.
Brad,
unless you got something else.
Nope, Brad had a good point that I completely forgot about. If you did the I can't even talk.
Calculate in parallel. Yeah.
In parallel, and then we could have showed you guys those as it was calculating behind the scenes. But yeah, thanks for pointing that out, Brad.
That is correct. Yeah, we talked about that in a previous SolidCAM live class, and there's been many CAD/CAM videos and tips and trick videos on that. We didn't do it because one, we forgot, and also we need to fill up time. We got 30 minutes to fill up. But you can see that it's going to calculate, and under these different index positions with the Z pointing in different directions, the tool will approach from those directions, recognize the stock. I wouldn't be surprised if the fourth 3D iMachining has nothing to machine. It might just have a little bit of a sliver of material that's left to machine, but you'll see that the more you go around, the less material there is. So the cycle time actually will get reduced as you go along as well.
Yeah, and that's like I was telling you guys with that 3D machine, it's so nice to have because it's all based off of that updated stock. So there's literally no thinking that you guys really have to do, as well as worrying about constraint boundaries to only cut what's left over and all that stuff. So. Now is where you need the Jeopardy music.
Yeah. Or the Mission Impossible music.
Yeah.
It's gonna blow up. But basically, as far as I know, Kevin, the top row is the one calculation it's doing here, and then this is the actual entire toolpath, right?
Correct.
Like, okay, and then you can see the multi-cores engaged there as well.
Yeah, and you know, the question we get asked a lot on the support line is, what computer should I buy? You know, what's the best computer to go with? Now, at that point, it depends on how much do you want to spend. Because you know, you could say that you want the fastest car out there. Well, you're going to have to go out and buy, you know, $1.5 million Bugatti. But you know, if you guys, some key features just to look at is, don't go for a Xeon processor, but get something that does have, you know, 8 cores. And the nice thing, or one thing that you guys can get is, the higher the clock speed, the better off you're going to be. So I just seen one of our customers bought like a 5.4 gigahertz clock speed. I didn't know they even went that fast yet, but that is out there for a fairly decent price too. But the clock speed definitely does help, because that's your horsepower as well.
Yeah, and here's a section from our website where we put out those recommendations. So it's some of the stuff that Kevin's talking about, but it's also a little more easier to just look at the names. Basically, we always recommend some sort of NVIDIA Quattro card. And then in terms of clock speed, I don't think it's actually on here, is it? But
no, I don't have the clock speeds on here.
They don't have it on here. Yeah, well, we do get that question a lot. Okay, so this is doing one at a time. So there you go. But if I can't zoom out, but you can kind of see that now this one was at the 90-degree area. It's actually recognizing that some of that stock was already removed from the 0 degrees one, so there's actually no toolpath over there. It's machining all that. Once this third one is complete, you'll see that it's pretty much just going to ignore any kind of air that's over here. And then on that fourth one, it should probably just look like just a little bit of a straight line. But we can let this calculate. If there's any other questions, any other topics we can cover today, we're near the end of the session. So what we'll do is we'll pretty much, if it's something we can answer right now, we will. Otherwise, we can just record it, and we can save it for Tuesday, unless Kevin wants to do it when I'm gone. to send us your topics, your questions, anything you want us to cover. Kevin's going to put my email in the chat section. You can email myself.
Birthday cards. You can send them to Mark there as well.
Yeah, don't send birthday cards. Hey, you know what? That's on you guys. If you want to ship it all the way up to Canada, that's fine. So, chat area. My email is there. Kevin's email, you already have it as well. If you don't, you can get it from the KevCam videos, or if you want, Kevin can put it in there as well. Any topics, any questions, anything you want us to cover. If you are looking for personalized training, you can always email me as well. Just let me know the day and time that you're free, and we can get scheduled into a GoToMeeting personalized training over the phone using GoToMeeting. Take a look at your parts, troubleshoot any issues you have as well, or just focus on strategy or just how to do particular toolpaths. If you know anyone that could benefit from SolidCAM, let us know. Any kind of contact info you give us, if they get into a demo, it sounds like we're giving out a $100 for just the demo, and then if it goes to sale, there's actually a percentage involved there as well. So it's to your benefit to not only use SolidCAM, because it's a reduction of cycle time for yourselves, but also if you help us sell it, you get a little bit of something too. So it's if you've got anybody that could benefit, let us know. I want this to calculate. There it is. Yeah. So what I could do is we could take a look at this part. I guess in the next class, I can send this to Kevin so you guys can see it tomorrow.
We'll just take a look at it on Tuesday, and then we can see
what on Tuesday. Sure.
The finished results would be for you.
I mean, you can imagine what this is going to look like if it's done with 3D iMachining, but the wireframe is what I think would be a little more interesting, because what happens is you can see that as it goes along, it's taking less and less material. But yeah, we can take a look at this in the next class. We'll end it here. So stay safe, keep your family safe. We will talk to you. Kevin will talk to you tomorrow. I'll talk to you guys on Tuesday.
All right, we'll see you guys tomorrow.